So we saw the various layouts for visualizing the graph. We had seen spectral, random, spring and so on. Now there is another nice command which will give m dot order. It says order and then brackets like this. What is it going to do? By order we mean the number of vertices. See, it's showing 70. Initially I had chosen m to have 70 vertices. And now if I give m dot order and brackets, it's showing me 70, which says that there are 70 nodes in the graph. Similarly, m dot size. You must be guessing what size means. Size means the number of edges which the graph will have. Let me check. Whoa, it is having 2415 edges. This graph is quite big, you see. Now, there are several more things which we can do with nx dot. Let me check nx dot tab. If you give, you can see here the various options. Nx dot graph, nx dot digraph, multigraph. Well, you'll be learning all of these in the coming week. For now, let me check something which is very relevant to whatever we have learned. Okay, let me go to classes, circular, community. Let me say G, something like, yeah. Do you see something called graphical here? Now, let us see how is it helpful for us. Well, I'm going to do something like this now. nx dot is graphical and I'm going to give a question mark. You see something written here? True if the sequence is a valid degree sequence and false if not. Well, this is very much self-explanatory. If I give a sequence and if I ask if the degree sequence is graphic or not, we have used the word graphic earlier. They are using the word graphical. Well, it means the same. You will know if a graph can be drawn on the given degree sequence or not. So it will give the value either true or false depending on how and what the sequence is. So let me define my sequence L to be in square brackets 2, 2, 2. And now what I'm going to check is it graphical? Well, you had already seen that it's not nx.graphical. If I give this, it's going to show up an error. So what I'm going to do is nx.is_graphical. So now, and then in bracket, I'm going to give the sequence L. Yes, it is true. If you remember, we had already seen this in our earlier video. 2, 2, 2 will give a triangle or a C3. C3 means a cycle with 3 nodes. That is the graph on this degree sequence 2, 2, 2. Now, let me check for some other sequence. L equals, I'm going to use the same alphabet. L equals 2, 2, 2, 1. Let me check if this is graphical. What I'm going to do is nx is graphical. You can always use your up arrows on your keyboard and to get back your previous command, whatever is relevant there. nx.isGraphical L and it says false. Now, my question will be, you must be guessing why is it false? You must know the reason because you have just one odd degree, whereas it should be even number of odd degrees, right? For a sequence to be graphic. And hence it is showing false here. Now, let us check with the sequence which we had earlier taken up. That is 5, 5, 5. Oh, sorry, it's 5, 5 and then 3, 3, 2, 2, 2. Well, this sequence we had already learnt it earlier. Now, let me check if it's graphic. Well, yes, it is. We are able to verify our results now. And the last one, let me take it as L equals, well, you can always use some other alphabet. I'm just using L for convenience. 5, 5, 5, 5, 2, 2, 2. This is my sequence now. Let me check if it's graphical. NX dot is graphical of this sequence. Gives me false. Well, this was a challenge question for you guys if you remember in a video. And we had also shown that it is not graphical. We had seen a beautiful video where we had shown the exact reason as to why it is not graphical. If you remember, we had seen that the last sequence had some negative numbers as degrees. And hence, it is not graphical. With just this one-liner is graphical, we could just play around and find out if the sequence is graphical or not. Well, do not assume that things can be this simple. Several people are working behind the convenience of this one-liner. What is that? Let us see. Do you see this here? Do you see this window? The source code for NetworkX algorithms. Well, behind this one-liner, we have the entire program written, and hence this is making our life very simple. This is the code written for finding if a degree sequence is graphical or not. Do you see this? Well, it's very huge. This is a documentation which people have done for this NetworkX. You can see that every such code used in NetworkX has a huge source code like this. So we must be really happy and we must use the resources available to us in the package NetworkX. Let us now go ahead and check a new graph. We have already seen what is a path graph. I'll name it as P here. Let me see how we can draw a path graph. NX P equals NX dot path underscore graph, and as earlier we had given the number of vertices in brackets, we should be mentioning the same here. Path graph on, let me say, 5 vertices, and then we have to draw it. NX dot draw. I'm going to draw my graph P with labels as true. Do you see the graph here? We've got a path graph on 5 vertices. This is just a random path graph. Now, we have already studied the concept of cut vertex and cut edge. If you remember, a cut vertex is a vertex on whose removal the graph becomes disconnected. Right? Well, now let us see how we can check that here. Now let me make one point very clear. As we have seen cut vertex, it is also called as articulation points. Now, this command nx dot articulation points underscore points in the bracket the graph P. Now, this is going to give me the cut vertices. Let us see. Well, do you see some command coming as your output here? Some line, generator object articulation points at, and some phrase. Well, this is not giving us the list of all the cut vertices. So what we have to do right now is list and nx dot articulation points of P. Please remember to give the syntax very accurately, as a small error might lead up to you not getting your output. So nx dot articulation points. Let us see if this gives us the list. Well, 3, 2, 1 it says. So the vertex 3, vertex 2, vertex 1. These are our cut vertices in this graph. Now, let me just create another one. Say R equals nx dot path graph on, let me say, some 12 vertices. It's a path graph on 12 vertices. NX dot draw R with labels as true. Well, do you see this graph here? It's a path graph on 12 vertices. Let us just see what are the cut vertices. Articulation points. Again, you got the same phrase here. Now, list will solve all the problem, but please note, it has to be list nx dot articulation points of this graph R. If you give P, you're going to again get the same list. So your graph matters with whether it is P or R. So articulation points R will give me the list of all the vertices which are cut vertices here. Now, what is the command for cut edges? It's a challenge for all of you to find it out all by yourself. Let me create a graph now. Observe these graphs here which I have created. Now, let us check if the graph is connected or not. If you remember, we had showed that by connectedness, there should be a path between every pair of vertices A and B. Now, let us check using this command nx dot is connected. And which graph? This graph. So you must check if this graph is connected or not. How do we do that? Is connected is the command for that. False. You see, this graph is not connected. As we had seen for graphic, it is the same for connected. The command is connected. Now, let me show you a star graph here. You had already seen what a star graph is. I had earlier done it. A star graph looks something like this. Don't worry much, you'll understand it. Nx dot star graph on, let me say, 11 vertices. Now, nx dot draw S. You see, this is called as a star graph. Okay, we had seen such a graph earlier. Now let me ask if is connected S. Well, you must jump and tell me that yes, it will be true, and the command is verifying it. It's a peculiar property of the star graph. You see, there are 11 vertices outside on the periphery, and in the center is one vertex. Whenever we give this command star graph in bracket the number of vertices in NetworkX, it means that the number of vertices inside bracket is actually those which lie on the periphery, these ones. This vertex which is in the center is not counted, and hence here 11 means all the 11 vertices which are lying here. So this is a star graph. We have seen that a star graph is connected.